Meeting is being recorded. This meeting is being recorded.
Hi, my name is Prateek and my teammate's name is Shreyansh, and we are implementing a project on path planning using artificial potential field approach. So the current progress of our project is as follows. We have analyzed the traditional artificial potential field method and implemented it on a 2D grid. The cells on the 2D grid are assigned weights based on the Euclidean distance between the robot position and the target position and the Euclidean distance between the robot position and the obstacle position. Our basic goal is to overcome the limitations of the traditional APF method, and the problems we have identified after implementing the traditional APF method are as follows. So the first problem that we have identified is oscillations near goal or target position. This happens when the obstacle is very close to the target and causes the robot to oscillate near the target and never reach the target. The other problem is goal not reachable near obstacle, which is abbreviated as GNRON problem. Here in this figure, you can see the oscillation condition detected near the target and also the error message that is generated on the terminal. The solution we have proposed are the improved APF method. So this method modifies the equation for repulsive or attractive forces to overcome the limitations. The other method will be explained by my teammate Shreyansh.
Right, so after problem identification, the goal is now to have a better method or the upgraded version of the APF. One way to do it is using the hybrid approach, which means fusing the APF with other algorithms like BAS or A star. When we combine A star with APF, it generates a smooth curvature for the path as shown in the figure on the right hand side. And it can come really handy for vehicles with kinematic constraint such as radius of curvature. In this method, firstly, the path is found via A star, and then each point on the path is act as target for the APF to smooth the curvature. Next slide, please. We have now limited our scope from the dynamic environment to the static after discussing with the professor, and we now intend to implement this method for the static obstacles, and for our extended goal we tend to implement it in the 3D world. Now for our results, we have successfully defined potential field for the 2D grid using the formulas shown in the previous slides. And using these potential fields, we were successfully able to find the path between the start and goal position as shown in the figure here. And one of our major result was the problem identification of the oscillation problem near the goal was successfully found in this method. Now, and now for our timeline, we have successfully completed our February deadline and implemented the traditional APF. And for now, March and April, we now intend to look for the better methods and implement them successfully. Thank you so much.